We're going to work with weighted averages with a few of these examples. So you are taking a class in which your grade is determined from quizzes, 15% total, then 3 exams, each of which receive a 15% each. Homework is 10%, final is 30%, and then they give you your average for the quizzes, the 3 different exam grades that are worth 15% each, and the homework mean, which is 85%, and your final, which you have an 89. So here's how you do it by hand. So you take each of these and you multiply it by their percent. So as you can see here, there's your 15%. Let me do a different color. Yellow. There's your 15%, which is up here. All right. And then you have your 15%. Now, each one of these are 15%. So you would actually do 78 at 15%, 81 at 50%, and 92 at 15%. And then homework is 10%, and there's your final. All right. So one of the things, you multiply all those out, and you add them up the points. All right. So we multiply these out, and here are the points. Now, this morning, it just occurred to me, I was like, oh, wouldn't it be nice if there was a way Staplet could do this? And let me show you what the problem is, all right? So what do we have for our grades? We have 85, 78, 81, 92. So I'm going to go to discrete random variables, add a couple rows. 85, 78. Actually, let me do this over here on the side so I can see it. There we go. Why is this blocked? Okay. There we go. That's what I want. So we have, there we go. I can see them all now. 85, 78, 81, 92. And I didn't do this for a couple of years because I was like, oh, it's not working. Then something occurred to me. So this is something called a discrete random variable. And the main thing is all these values should be unique, right? Not the probabilities, that's fine. And then we got 5. A probability is like your average homework. We have an 85. And then we have final. So when I used to try to do this, I was like, okay, yay, I'm going to let Staplet do it for me, right? Here's the problem. If I hit begin analysis, it doesn't like it. Here's why. Well, maybe 85. And then let me hit begin analysis for some reason. Okay. Wait, there we go. It's probably freaking out because I'm going to just actually refresh it because I think I broke it. So the problem that we have is there are 2 85s. All right. So what I'm going to do is I'm going to combine the 2 85s. Exit the page. Sorry, guys. Snap. Let me go back in. And so I know there are 2 85s, so I'm going to put 85. But instead of putting 15%, there are 2 of them, so I'm going to put 30%. All right. Then we have 78.15. Just do a couple rows. Then we have 81.15, 92.15. I already did the 85. Oh, let's see. That was 10%, so this should be 25%. And then we have, how did I get the 25%? I got the 15% from the top one and the 10% from right there. And that's 25%. So I got my 10%, and then I have my final, which is 30%. So all of these need to add up to 1. Oh, look, it worked beautifully. So if you scroll, there is your mean, 85.6, and your standard deviation. So the cool thing to do is if you have a value that repeats, you can use the Staplet as long as you just combine those repeated values. All right. So now, what if the quiz mean is not really an 85? Oops, hold on. Okay, so now let's go to part B. And you saw how I got the 85.6. Whoops, I didn't mean to do that. Let's go to part B. What did the quiz mean really is not an 85, but each of the quiz scores are, and you count only the first 4 best grades. So the easiest thing to do is to do the average there. Luckily on the grade book, I can say drop 2, and it knows which 2 to drop. It automatically does the bottom 2. So you do have to, because we're not the grade book and we're not programmed like that, you have to go and cross off the bottom 2, okay? So we have the 83, the 100, the 67, and the 75. Add those all up. Now, if you're using a calculator, either TI or other, you got to be a little bit careful. So let's see, we have 85. Oh, that looks like I have a little typo right there. That's supposed to be 67, isn't it? All right. Let's see if I can paste these in the calculator. So, nope. What do we have? 85, 83, 100. Or I could just actually put it on the Stapplet. Control C that. Come on. There is my Stapplet. For that, if you're just doing a straight average, you just want the one quantitative variable single group. And you can just paste your data in here. I don't need the pluses, though. It's going to freak out with the pluses. All right. Begin analysis. And it says your average is 81.25, which is what you get here. So if you don't have the calculator, but honestly, it's easy enough just to add the 4 up and divide by 4. So what you could do, now we can have a new average of 81.25. So if I go to that Stapplet, I have to do my data in again. So let's get ready. Let me scroll back up. Now we have the 81.25. And that means now that my grades are different. I think it's my clicker's not working so well. Not sure. Okay, Alt-Tab. Let's go here. And there we go. Now it's finally working. And I go back to that discrete random variables. Now, instead of 85 for the quizzes, I have 81.25. Put in your original values. Then I have that first test, which is 0.15. And then we have 81, which is 0.15. And then you have 92, which is 0.15. And 85, which is fine. It's not a repeat anymore because that's the homework average and the quiz average changed. And then finally the final, which is an 89.30. And begin analysis. Oh, let's see. Oh, that's not supposed to be 0.5. By the way, it will double check your values. So that's kind of nice. There we go. So now you can see there's our scores. I don't know what. Oh, those 2 bars are really close to each other. And you can see your new average is 85.037. Now, another way to look at this is you're like, oh, my old grade, I had, my new points average, if I took this and did it by its weight, just by itself. So I'm kind of doing this math up here with the quizzes on the top line, but I'm replacing the 85 with the 81.25. My old points, let me go ahead and highlight those. My old points were 12.75, right? But my new points is 12.1875. So what's the difference? It's this. So it goes down by that many points. So I can just take my old average without having to redo the whole thing and subtract that. So it's up to you how you do it, but it's nice if you understand how the whole thing works. Now, using the results from Part B, if the teacher made an error scoring the first exam, you should have gotten an 87, not a 78. What would your grade be now? So we're still keeping the 81.25, right? Well, luckily, I can actually just go back to my Stapplet, go up, and what did they say? It was not, should have gotten an 87, not a 78. So I can just change that data. Begin my analysis. That's fine. Begin analysis. None of the data repeats, so it should work. And boom, my new average is an 86.38. Same as we got here. So you can do it with the Stapplet, or you can actually go back and say, okay, what are my new exam points? Shows my old exam points. So it should go up by this difference. So let me pick a different color here. We'll go purple. So here I have 39 points. If we go up, I had 37.65 points. And so it should go up by the difference, which is 1.35 points. Or you can just put it in the Stapplet and boom, you have your answer for the new one. So you just edit that out. Okay, next one. For each problem, determine whether the mean or median is more representative. And luckily, we have Staplets, so we're just going to use that instead of a calculator to calculate our means. Let's do one quantitative variable, single group. And it gives us our mean and our median. Now, the median's easy enough because they actually listed we listed the data in order, right? So we know the median should be 1, 2, 3. There's your middle point right there. So right there's your middle point. So we know our median is 17. We actually need a little bit of a calculator for the mean. We'd have to add them up and divide how many data points, or we could just say, oh, Stapplet, what is it? 44.875. All right. Actually, I really like doing the Stapplet on this, so come on. My mouse is not being very nice today. Here, let me reattach. There we go. Are you working? There we go. So yes, there we go. And I'm doing text. I want text. There we go. Lots of there we go. Sorry. What did we say the mean was? It was 44.875. So which one is more representative? So if you look at that dot, you can see it's very heavily skewed, all right? So you've got most of your data is down here. Copy that. Go put that back here. So you can see it's very skewed, and we have an outlier here that is pulling the mean way up from the median, okay? So that's what's going on here, and that's why we prefer it. The median was the better choice right here. So we say median because of skew. All right. And then we have, now we have another set of data. We can, again, I think these are all in order, so the median might be easy. It's an even set, so I'm going to think the median's 0.35, all right? But we'll double check it with the Stapplet. So let's change our data, edit inputs, put this in, begin analysis, all right? And you can see that the median, I'm sorry, 0.35, why did I say 3.5? I was right on that, and the mean is 0.325. So let me go ahead and 0.35. And the median is, I'm sorry, 0.325 for the mean and 0.35 for the median. And here your answer is either one, all right? Oh, I guess I had it right there. They're about the same. And if you look at the data, let me go get the data. It doesn't look extremely skewed or anything. It just looks like some data, all right? So there's nothing to worry about here that I'm like, oh, I can't use the mean. No, you actually can use the mean on this one because the data is not all skewed, all right? And that is it for this page, which is class average examples.